No, the tree is not like a thicky.
Okay.
It ain't got it.
There. Okay. All right, y'all. I am so sorry that this is so late for your semester review. And I'm going to leave it up here long enough that you can look at it, write it, whatever you need to do. And then I will move it up in just a moment or two. I'm just trying to get it done, and I've got another class in here, and they are cooperating greatly with me, and I really appreciate that. But anyway, I'm getting you the answers. These first two really didn't simplify a whole lot. The main thing was that we got a common denominator, and then we combined the numerators. Okay, the numerators did not factor. I went over and tested it, and unless I made a mistake, they don't factor. So that's why we got what we got in the numerators. So I'll leave that up there for a moment, and then I will move it up. Thank you. Okay, now, complex fraction. So I found my common denominator for the numerator here, and then for the denominator. On the numerator, it's x. So this one has the common denominator, so it's just 1 plus, and then we had to multiply by x over x, so 1 plus 3x over x. Okay, find the common denominator down here, that's y. Okay, so we get 5 plus 4y over y. All right, now split this complex fraction up, take the numerator, multiply it times the reciprocal of the denominator. So that's why the 5 plus 4y went down and the y went up. And then it goes to that. Okay, on number 4, you need to pull a GCF out of each of the numerators and the denominators, and then you can start canceling out. Okay, 2x plus 1s go away, 2x minus 3s go away. Really, we could have done 2 into 4 and gotten a 2. So 2 times 7 will give us the 14. And then 7 goes into 21 3 times. Something's not right there. Oh, because that reduces more, that's why. So 7 goes in there 2 times, 7 goes in there 3 times. There we go. It really should be 2/3, not 14 over 21. Okay. The next page. Same thing. You're pulling GCFs out. So this factors to y plus 5, y minus 5 over y plus 4, y minus 4. Okay. Then you flip the second one and multiply. So we pulled a 2 out, and then we're left with y plus 5 down there. And then we can pull a y out. So we have y times y minus 4. And you cancel what you can, top to bottom. The y minus 4s go away, the y plus 5s go away. And then you multiply what's left. And that's what you get there. Okay, these other ones are equations that you solve. Okay, so I'm going to put those up and give you some time to look at that. And then I'll move it up again. Okay, now the last page of the first part. I hope it's the last page. Maybe it is. All right, not quite. All right, sine, cosine, tangent stuff. There's that. Now, the last sheet here. There we go. Switching from exponentials to logs and from logs to exponentials. And then the last solving. All right. Okay. Now, for the fun one, the trig identity page. Okay, the first one's not too bad. Okay, change 1 plus tangent squared to secant squared. And sine squared plus cosine squared is 1. So secant squared equals secant squared. That one's fast and easy. Okay, let's jump to the third one real quick. We'll come back to the second one. It's quite involved. I worked it 2.5 times before I got it to match. So here, I started looking at this side. Okay, and so that brought us down to cosine to the 4th x. And then you're just left with the first parentheses, 1 minus 2 sine squared x plus sine to the 4th x. Okay, now this 1 minus 2 sine squared plus sine to the 4th, that factors into 1 minus sine squared and 1 minus sine squared. Okay, then 1 minus sine squared, that's cosine squared, so that's cosine squared. So cosine squared times cosine squared is cosine to the 4th equals cosine to the 4th. So that one wasn't bad. Okay, now the second one, though, was more of a doozy than I meant for it to be, but it came out of the book. Y'all know I don't make these up because that would be a disaster. Okay, so here we go. All right, so I cross multiply. Okay, sine minus cosine times 1 plus 2 cosine sine. Okay, I think I said that backwards, but that's all right. All right, so that's where I get this first step. And then I did sine plus cosine times 2 sine squared minus 1. Okay. And then I got this right here. Okay. So, and I've triple checked that. So that I feel good about. Now, so what I did was I kind of cleaned up the trailers. And by trailers, I mean the minus sine x and the minus cosine x that we got when we double distributed or FOILed these together. So I added sine x and I added cosine x to both sides. Okay, it made the cosine x go away, but we ended up with 2 sine x. Okay, and then I brought down 2 sine squared x cosine x minus 2 sine x cosine squared x equals 2 sine cubed x plus 2 sine squared x cosine x. Okay, then the next thing I did was I pulled 2 sine x out of each piece here. So I pulled a GCF of 2 sine x. Okay, so that leaves us with a 1 there. That leaves us with a sine x there, cosine x. And that leaves us with a minus cosine squared x there. Okay, so then over here, I pulled out a 2 sine squared x. So when I pull 2 sine squared out, that leaves me with sine. And when I pull 2 sine squared out there, it leaves me with the cosine x. Okay, so now I'm looking at what was in this parentheses. And I've got 1 and a minus cosine squared x. That gives me a sine squared x right there. And then we have plus sine x cosine x times the GCF of 2 sine x. But looking at this, I can pull another sine out. So this becomes 2 sine squared x. I'm left with 1 sine here when I pulled another sine out. And I'm left with just the cosine here when I pulled that sine out. Okay? So this one just came down. We didn't change anything. And looky there, we've got sine x plus cosine x. And then our GCF on both sides was 2 sine squared x. So we're done. That one was a little messy. All right, so hopefully this will help. And I'm going to get Amiel to text Maddie. Do you have Jenna's number also? Maddie and Jenna, and then if you all would make sure everybody else, Reagan and Bree and James and Tiger and Sylvia, I think that's all of y'all. If I missed one of y'all, I'm sorry. But make sure that everybody gets it now. So I'm uploading that to Google Classroom right now. Thank y'all for being so very cooperative. I really, really appreciate that.